Okay, well, let's tackle every sort of problem that we might come across. In this case, I'm looking for a z-score that's greater than 1.15. I know that's on the right. It's asking me to continue to go to the right, as the arrow says, so I know that's a tail. The answer is 1251. The next problem, this suggests a body. I have a z-score 2.10. I want to know the proportion or the probability of grabbing one value that's less than a z-score of 2.10. So I'd start on the far right and go to the left. That's clearly a body, 0.9821. Next problem. When the values of z fall on both sides of 0, we can add the column D values. So in this case, I want to know what proportion of z-scores fall between negative 1.5 and 2. And I'm able to just add the guts, if you will. Those are column Ds. There's no problem at all. That one's kind of an easy one. It's easy to conceive of it that way. And sure enough, that's a huge majority falls between those two z-scores. Now, what if they fall on the same side? So in this case, I'm asking what proportion falls between 1 and 2 standard deviations above the mean. You'll remember, again, that we have 3 different ways of doing this, of which you're happy to just pick one if you want. So in this case, I could subtract the larger tail from the smaller, the smaller tail from the larger. The smaller tail from the larger, it will always be a positive value. And you can see the larger tail is 1587, the smaller one's 0228. Subtract 1 from the other, you get 1359. Another way to do it is we can calculate the area using 1.0 minus the smaller body minus the smaller tail. So the entire one, the smaller body is 8413. That smaller tail going to the right is 0228. And sure enough, it comes out in the wash again. I mean, it's amazing how the math works out that way every time. I'm looking to leave that portion that's between the goalposts, if you will, and I'm subtracting away the other whites parts that get in the way, as it were. And here's one final way. When the z values fall on the same side, we can subtract the smaller body from the larger body, just as we did before. So 9772 minus 8413, again 1359. Comes out the same way, either way. But I'm left with that sliver in the middle. It's really not that bad once you start to conceive of it. Now, here's a couple of questions that make us convert to z. Then we subtract the smaller tail from the larger. So in this case, let's say we have a population of happiness scores, and they have a mean of 80 and a standard deviation of 10. Who knows what that is? And I want to know what proportion of scores falls between 60 and 65. Both of those are below the mean. And I have to solve for z for each of them again. I've got a z of negative 2 and a z of negative 1.5, just as we did here. I'm converting to get those z-scores. And sure enough, I can undergo the same process. In this case, without belaboring it, I just took the smaller tail and subtracted from the larger, and we got 0440. So again, I could have done it 2 other ways. But nonetheless, the point of this problem is just to show that we have a real world problem. I have happiness scores or needles on an evergreen tree or heights of giraffes or what have you. Anything that's normally distributed, I want to get that in there and convert to z first, which I can always do. Now here's one, and this will be the last problem we do. I've got a percentile rank, and I want to know, hey, what value of happiness is at the 40th percentile or separates the top 60% from the bottom 40? Now, from the tables, this is as close as I can get. It's a z of 0.25. However, I know that z is negative. It has to be negative. If I've got a percentile rank that's below 50, the z-score is necessarily on the left side. We're talking about, with a percentile rank, the proportion that falls to the left and lower and to the left. So the z-score is going to be negative. Now, when I plug that in, it gets a ticky just because it's negative. So I've got 80 plus a negative 0.25 times the 10. And of course, that's just 80 minus 2.5, which is 77.5. So it's not that tricky, but I like to use parentheses where possible, just to really delineate things. Maybe I could have said 80 minus 0.25 times 10. But as you can see, it comes out in the wash. That plus just disappears because we're adding a negative. But really, this is the gamut of almost anything I could possibly ask that has to do with a normal curve. I mean, whether I'm converting to Z or the Z score is already expressed in a simpler version, as you can see, it's fairly accessible. Not a terribly difficult problem. And by the time you're finished here, you'll get very, very, very good at using the Z tables. They'll be second nature, and you'll accidentally memorize a lot of them. You'll be surprised.